Hi everyone. In this video, we are going to discuss about one more example of the transmission line. So that is, the given example is a lossless transmission line has a capacitance of 50 picofarad per meter and inductance of 20 nanohenry per meter. Find the characteristic impedance of a transmission line 10 meters long and 50 meters long. So given that lossless transmission line is there, solution. So given that lossless transmission line, for a lossless transmission line, for a lossless transmission line, the characteristic impedance is equal to characteristic resistance, that is Z0 is equal to R0, which is equal L by C, and given that the inductance L is equal 200 nanohenry per meter, 200 nanohenry per meter, and the capacitance C is equal 50. So given that the capacitor C is equal 50 picofarad per meter, 50 picofarad per meter. So determine the characteristic impedance 10 meters long and 50 meters long. And the first bit, determine the characteristic impedance 10 meters long. For a transmission line, of length, for a transmission line of length 10 meters long. So 10 meters long mean L is equal to 10 meters. So 10 meters, L is equal to 10 meters. L by L is equal, L is the, capital L is the inductance and small l is the length of the transmission line. So L by capital L by L is equal. So what is the inductance? Given that inductance L is equal to 200 nanohenry per meter, 200 into 10 to the power of minus 9. So therefore the inductance L is equal 200 into 10 to the power of minus 9 into length of the transmission line. Now here 10 meters long, L is equal to 10 meters into 10. So that is equal 2 into 10 to the power of minus 6 henries. And now calculate and similarly calculate the capacitance. The capacitance C by L is equal So what is the capacitance value? 50 picofarad, 50 into 10 to the power of minus 12, and the capacitor C is equal 50 into 10 to the power of minus 12 into L. So what is the small l? 10 meters long. So that is equal 5 into 10 to the power of minus 12 minus 10 farads. So now calculate the characteristic impedance Z0. So for a lossless transmission line, what is the equation of the characteristic impedance Z0? Z0 is equal square root of L by C. So now here L is equal 2 into 10 to the power of minus 6 henries, and capacitor C is equal 5 into 10 to the power of minus 10 farad. Square root of L by C is equal and substituting L and C values, we get the characteristic impedance Z0 is 62.245 ohms. And that is the first bit solution for the 10 meters long. And the second bit solution for the length of the transmission line, for a line of length. Now here length of the line is 50 meters long. So L is equal to 50 meters. So therefore the inductance L is equal 200 nano Henry 200 into 10 to the power of minus 9 into 50 meters long into 50. So that is equal 10 into 10 to the power of minus 6, and the capacitor C is equal 50 into 10 to the power of minus 12 into 50 meters long line is equal 2.5 into 10 to the power of minus 9, 10 to the power of minus 9, and henries and farad. And therefore the characteristic impedance Z0 is equal square root of L by C, and substitute L and C values, we get the characteristic impedance value is 63.2455 ohms.